God, the heat is just brutal, and my dash cam mount just melted off. Well, it didn't melt off. My God, the heat is just brutal. My God, the heat is just brutal, and my dash cam mount just melted off. Well, it didn't melt off, but it got soft. Jeez. There's the storms coming south out of Oklahoma. Well, anyway, that's what I was doing today. Errands in 102-degree weather. It's not my favorite thing to do, but we are desperately needing a change here. This heat has just been brutal. This is what the map looked like, and it looks like we are finally getting that relief. Got a big front washing into Arkansas, into Texas. There's the leading edge. I'm using a mouse, so I can't really put these barbs on there correctly, but that's about what it looks like. And that's being driven by high pressure up in the Dakotas. Let's take a look at the source region. The high isn't particularly strong. The highest pressures I'm seeing in this area are 1019 millibars up in Montana. There's probably even higher pressure up into Saskatchewan and Alberta, but we're getting this very broad, deep flow coming all the way down from Canada. So it's a nice change. We can get a better look at it with the thickness charts. This is College of DuPage. So we can start cracking out the thickness charts, and overlaid on that is the surface streamlines. That's these dotted lines that are like that. And we can see that there's low pressure right there. It looks like there's a high in Colorado, and maybe some ridging up into Alberta. But the main thing that I'm looking at is the thickness gradient. That's where the dashed red lines are packed very close together. So that will tell me very quickly where the warm front is that's associated with this low here. And that works the same way with the cold front. Of course, that's not going to match up perfectly with the surface data, but when you're over a mountainous area, this helps bring all the temperatures to a common level where you can more easily compare them. So when we're seeing these systems crossing the Rockies, I will tend to use thickness a lot to kind of monitor it, especially when I lose the positions. Out to the east, there's a bit of the Bermuda High driving some southeasterly southeasterly flow into the eastern U.S. and let's take a look what it looked like out east. They've got some very hot weather out there too. In fact, you can see dew points there at this is Dover Air Force Base. They got 82, got 81 here, somewhere looks like east of Baltimore. So very humid conditions all the way up to New England. And relief for them is still probably a day or two away. It's because if you go out to the east, or out to the west, still got 80s and southerly flow over Ohio. And it's not until you get to the Detroit area where you start picking up northerly winds, cloudy conditions, and 70-degree weather. Okay, this is the SPC mesoanalysis, and this combines the radar with the surface chart. So here around Temple to Austin, you can see this outflow boundary. There's a bunch of them like that. So these are very outflow dominant storms, and they're probably going to be a little bit high based. And the reason I'm saying high based is because we've got a temperature dew point spread of about 30 degrees. So with that, we're usually talking about cloud bases over 5,000 to 6,000. So it's kind of a broad area of showers and thunderstorms, and this is moving southeastward pretty quickly. So I don't know how long this will hang on tonight, but we may see that coming to the Austin and San Antonio area, and maybe all the way to Houston later as possible. I had a GR level 2 going, and it's definitely changing from minute to minute since everything is moving quickly. So we got these showers from about Athens to Corsicana, all the way down to Waco and Temple. And once we get further out in this area, we start overshooting the tops of those cells because they're not particularly tall. The echoes fade at about 26,000 feet. By the time we get up to the 1.8 degree tilt, 27,000, they wash out. So these are not particularly strong thunderstorms, which I guess is good. It's the relief that we want. The rain would be good, but we definitely don't need the gusty winds. That could definitely be a problem during the summertime with some of these organized thunderstorm cells. And that's a final look at the cold front coming down south through Texas. Probably didn't sketch that on very well, but man, it's all the way down to Kerrville and Fredericksburg. So yeah, that's going to be in the San Antonio area probably in the next maybe 1 or 2 hours. So that should keep things cooled down. The air is going to be heavily modified as it comes across the warm central plains, but that should knock things back about 15 or 20 degrees. Probably still a little bit on the warm side at night. So what we're looking at nationwide, we've got a couple heat advisories there in Arkansas and Texas, and it's quite a few of them out there near New Jersey and New York. And then in between that, it's like a couple flood watches along the, I'm not sure that's the leading edge of the cold front is not that far east, so there's probably some sort of weak front through here. I would have to look at the surface data. And then this here is definitely along the front there, around Midland and Hobbs. So that's pretty good. We got a big change. I don't know of anything else I can show you right now. Maybe just look at the soundings real quick. I don't think we have the 0Z soundings in. Pulling up the Fort Worth chart here. So we got a little bit of an inverted V here. This is at 12Z, so this is about 12 hours ago. But if we overlay 100-degree readings, which is probably what the area south of Fort Worth had earlier, and then I think dew points were running about 66 or so, that's going to be about 19 Celsius. So that's what our lifted parcels are going to look like. So a very wide area here indicating a high LCL. In fact, that's up at about 8,000 feet there. And it looks like maybe a few elevated. So that's the reason we're probably getting some of those cells in between. See that moist layer right there? So we got just enough layer to kick that off, or enough lift to get that kicked off. And above that, we got this thing called a cape robber. This was a big problem in a couple of chase years, like 1998. It's basically a layer of warm air in the upper levels of the troposphere, and it takes away some of the cape you would usually have. So if you had a sounding that looked like that, and then the environmental parts that look like this, so normally you would have this big positive area in between. But in this case, we don't have that because it cuts off to the right like that. So when we go to look at our cape, we see it's a lot thinner and skinny. So if we were looking at organized storms with a lot of moisture, a lot of lift, and we were expecting tornadoes, that kind of thing, we would consider that to be kind of a negative influence right there. Alright, let me check here. Let me make sure my sound is coming through. I've got to click something here on YouTube. Just give me a second here. Alright. I think that's about all I got for today. I appreciate you watching, and we will be back with you tomorrow night, and we'll try to show some more interesting and unique charts. And I wanted to get the astronomy stuff going. I've got a couple of eyepieces that came apart, and I have to put those back together. But I'm going to get that telescope out, and we'll look at a few stars and that kind of thing. Anyway, thank you, and we'll see you tomorrow night.